Hey, what is going on, guys? Welcome to Flat Tutorials, and welcome back to the maze generator series. And in the last episode, what we have done is we have programmed our system to create a closed grid for us by taking some parameters. Those parameters are x size and y size. So it basically generates a closed grid of cells. Okay. Now what we're gonna do is for our convenience, what I'm going to do is I'm going to go ahead and rotate the camera to 90 degrees and put the z-axis to 0, and I'm going to pull it up a bit, and it should be on top of the maze so that I can monitor it. All good. Okay. Alright, so yeah, it works pretty damn fine, I guess. Okay, now I can monitor what is going on in the scene. I'm going to go ahead and add light. So, okay, so let's get back to the tutorial. What I'm going to do is I'm going to make the system to remember some information for me. And that information is, hold on, let me show you what I'm going to do. Open this image. Okay, so I'm going to make my system to remember some information for me. So I'm going to create a class, and that class we're going to hold some values for me. Like we're going to hold basically what wall belong to which cell. Okay, so that's all that those classes we're going to do. But what we're going to do is we're going to create a custom class inside of the script, and yeah, that's pretty much it. We're going to create a custom class, then we're going to use for loops to assign those walls to those variables, and this is pretty easy, so let's get started. And yeah, let's get started. Okay, so if you open up the maze script, I'm going to open it up again. Okay, what we're going to do is we're going to create a new function, okay, and we're going to call it void create cells, because this will going to create cells for us. And we're going to call this function at the end of the create walls function. So once the walls has been finished, when the walls is done creating their stuff, we're going to call our function. Okay, so once the walls are finished building, we're going to go ahead and create cells for us. Now we need to create a custom class. Now you can do this using structures as well, but I'm going to use the class because I wanted to see what is going on in the inspector, and yeah, I just wanted to monitor the variables. That's why I'm doing it. Okay, so yeah, let's get started. So the first thing we need to do is to create a class. So I'm going to go public class. I'm going to call it a cell class, and yeah, now this this cell class will hold some values for me, and those values are, the first one is basically boolean, and it is a visited boolean. So this will gonna just tell us whether the cell has been visited by the system or not. Now that's it. That's all it's gonna hold. Okay. Now, the next thing that I'm going to use is the next variables that I'm going to create we're going to hold walls for me. Okay, so I'm going to go public, and I'm going to go north. Oh, sorry, it's a game object. I need to toggle that. Okay, so it's north. I'm going to copy this. I'm going to paste it 3 more times. Okay, so we're going to name our variables to north, east, west, south. Okay, so north, east, west, south. Now we are done with the class. There's one last thing we need to put in the top, and that is system serializable, and this will gonna make our a class to appear in the inspector. Now if I go back and compile it, I should not have any errors. Okay, we're good. So yeah, let's get back to our create cells functions. Now, sorry, function. It's only one function. Okay, so we're gonna get some value. We're gonna get some. Actually, let me tell you what I did in the last episode is I created a game object named wall holder. Now, this game object I created this game object to hold all the walls that I created for the maze. Now, there is a reason for that, because I'm going to use this wall holder to record all the walls for the cells. Okay, so I'm going to go ahead and create an array. I'm going to go game object and call it all walls. All right, and I'm gonna get all its children. Okay, so but first what I need to do is I'm gonna get how many children does this guy have. So it's gonna be sorry, children. I'm gonna call this wall holder dot transform the child count. Okay, I'm just gonna make it a little bit bigger so that you can see what is going on over here. Okay, I'm gonna get more space. Okay, now let's get all these children for us. Now I'm gonna go ahead and create a comment. I'm gonna go ahead and call it get all the children. All right. Now we're gonna create a for loop, and this for loop will, of course, my favorite. Integer I, which is going to be equal to 0. Well, and I should be smaller than children, which is basically the child count. Okay, now you don't have to create this variable. Of course, you can go ahead and put the values directly, and yeah, move on. Now let's move on. I'm going to go ahead and increment it every time we start the loop again. And yeah, let's store the value in the all walls variable. So we're gonna go all walls, we go I equals wall holder, and I'm gonna go dot, sorry, get child. Oh, it's a transform entity. I'm sorry, transform get child, and we're gonna get child at the index of I, and we're gonna take it as a game object. Okay, we're almost done. So this should store all the walls for us. Okay. Now once we have all the walls in a variable, we can use it to assign it to our classes. Now what I'm going to do is I'm going to go ahead and create an object for the class we have just created, which is basically the cell class. We're going to go at the bottom, and I'm going to go ahead and call it public. Now I'm going to change this from public to private later, but for now I'm going to call it public, and I'm going to call this one a cell. Okay, that's pretty much it. You're going to want to go down. Let's see if we are getting any errors. Oh yes, we do. All walls I. What is going on? Wall holder. The transform that child. Oh yeah, we didn't really assign the value or how long this all walls variable is gonna be. So yeah, that's a little bit problem. Okay, so we're gonna go all walls equals new game object, and we're gonna give this a number. So this is how many children basically we have. So yeah, it should be fine by now. Okay, let's run it. There shouldn't be any problem. Alright, now if we go back in the maze generator right here, we have cells class right here. So if I create any of these classes, you're gonna see we have some elements right here, which holds north, east, west, and south. Why is not Boolean showing up? Oh yeah, it's not public. So I'm gonna go ahead and make this public. Now there should be a Boolean. There you go. Okay. Now what we're gonna do is we're gonna go ahead and one more thing, if you are afraid that these values are not going to be same every time, you can go ahead and create a constructor for it. It will work just fine. Alright, now we're going to go ahead and create our cell process, which we're basically going to assign all walls to the cells. And yeah, so let's do this. So I'm going to create one more variable. I'm going to call it cell process. So it's going to be a basically integer. And we're going to call it cell. You know what? I'm not going to use it right here. I'm going to go ahead and create it inside of the for loop. So we're going to go for. I'm going to go create a comment. Assigns walls to the cells. All right. Now we're going to call it integer cell process, and we're going to start it by 0. We're going to go ahead and go cell should be smaller than cells dot length, and I think we haven't really decided what the length is going to be. Okay, so we're going to go ahead and get back over here, and we're going to go with cells, and we're going to go cells equals new cell, and we're going to give it a value. Now this value is basically total number of cells that we have in the scene right now. So it's basically x size times y size. So it's basically rows times columns, and that's pretty much it. So this we're going to create a cell process thingy for us, and we're going to go ahead and increment the cell process every time. Okay, now let's get back to it. Okay, now what we're going to do is we're going to instantiate the cell class for each cell object. So we're going to go cells. So you see it, cells, and we're going to call this one SubProcess, of course. SubProcess equals, and we're going to go ahead and instantiate a new cell, which is basically a separate class. Okay, I haven't noticed that block brace right here. Okay, so it should be working fine. I should just check it, and if I run it, I should have actually 25 cells, because 5 times 5 equals 25. Yeah, it is working damn fine. Now we'll go back to it, and I'm gonna go ahead and assign the first wall for the system. So I'm going to go ahead and assign the east, which is basically the left wall. So I'm going to go ahead and go cell process, and we're going to call this one a cell process. So it's basically going to go one by one to each cell and assign all the walls for the cell. I'm going to go dot east, and because this is the left side, east on the left or right? I don't know. So we're going to use east as left. I don't really know if it's on left or not, but we're going to move on with that. Okay. We're going to go all walls, and we're going to go, you know what, let's create one more variable. You can do it without variable as well, but let's just create it. Okay. We're going to go integer, and we're going to go ahead and create a variable. We're going to call it east west process and set it to 0. Okay, we're going to put it right here, east west process. So this is basically the value of cell process every time. You can use that as well, but I'm just gonna do it like this. Yeah, so let's move on. Now we're going to go ahead and assign the south wall for it, because it's easy. Okay, so we're going to go ahead and go cell process dot south, and we're going to get all walls, and now the south cell is basically calculated like this. So let's just consider it. We are on this cell, the first one. Okay, so yeah, first of all, the cell counter starts like this. So this one is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. All right. So we are on the first cell for an example, and we want to get the south wall, which is this one. So if you go ahead and take a look how we create mazes, if I go ahead and run it right here, I'm just going to close it. Okay, so in the section, in the maze game object right here, you can see how the cells are assigned, how the walls are created. So if I go right here, the first wall is basically the vertical one. So so first the vertical walls are created like this. Okay, so I'm gonna just back up a bit to show you. Okay, I don't really tell you how this works. Okay, so first the vertical walls are created like this. Okay. So it goes like this, and then there are walls that are created like the walls that are created horizontal, which is basically north and the south walls. So if I go ahead and take a look at it right here, so it's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and basically the first south wall is after the count of all the vertical walls, which is basically on the x-axis. So that's how we're going to calculate the wall. And we're going to go back right here. You'll understand what I'm saying in a minute. It's basically, we're going to calculate it like this. So we're going to go child, we're going to go ahead and we're going to get on which child we actually are. So in order to do that, we're going to go ahead and create one last variable. I guess it's one last, so I'm going to go integer child process. And it will start from 0, of course, and now we're gonna go ahead back to right here. So it's gonna be child process, we're gonna increment, and we're gonna go x size plus 1 times 2 y size. Alright, so it's basically going to take all the children, on which children you actually are, then we're going to add the x size times y size plus 1. So it's basically going to get the first wall that is created after all the vertical walls, which is basically the first south wall. So that's how we are getting this south wall. Now, what we're going to do is we're going to go ahead and assign it to the assign the west and north walls. Now, before we do that, we need to do something. So, if you take a look over here, so consider this: if you are, if I'm assigning like this, if I'm going cell by cell. So, if I'm on the first cell, and if I want to get the east wall, it's basically the value of the cell. So, if I'm on the first element, so it's, basically I'm on the 0 element, and the 0 element on the wall is basically the first vertical wall. But take this for an example. If I go like this, 0, 1, 2, 3, 4. Okay. Now when I'm here, you're gonna notice that here is something wrong because I want to get this wall. But if I go over here on the fifth one, it will basically gonna get this wall. Let's go ahead and do that. Now what we're gonna do is we're gonna create one more variable like this. I swear this is gonna be the last one. And we're gonna put it in an if statement, and yeah, so I think that will be it, but I'm not sure. Okay, so I'm just gonna go ahead and create an integer. I'm gonna call it term count, call it 0 as the default value. So this is the term count. I'm gonna go ahead and I'm gonna check if the term count is equals to x size. And what is x size? Let me tell you what is x size. X size is basically the last element on the x-axis. So I'm going to go ahead and increment the east-west process by 2, and we're going to set the term count to 0. And we're basically going to increment the term count every time we end the loop. So it's going to term count plus increment. Okay. That's a lot. Okay. So now once we are done with that, we need to increment the value of the child process as well, so that we are looking for a new child every time. Now we're going to assign the west and the north walls. Okay. Let's do this. Okay, so I'm just going to copy this right here. Okay. And we're going to assign west. and we need to increment the east-west process. Now, in order to do that, I'm just going to put an else statement right here. I'm going to go east-west process, and that's pretty much it. So now we have the west wall assigned. Now the only wall that is remaining is the north wall. So let's go ahead and do that. I'm going to copy the south wall, and it is basically the same calculation for the south, but it is on the opposite direction. So we're going to go ahead and go put north over here, and it is basically the exact same calculation as I said earlier. But what we're going to do is we're going to put this whole thing in braces. So this should be calculated first, and then what we're going to do is we're going to add x size -1, and that should be it. Okay, so the simple way to test it is I'm going to go ahead and go back right over here. I shouldn't have any error. Now we're going to go maze generator. We're going to go ahead and create a 1x1 matrix. Okay, just to check if all the walls are assigned are correct or not. Okay, so we are right here, element 1. Okay, so we're gonna guess this should be the north wall, which should be this one. So I'm gonna go ahead and check that. North wall, correct. East wall, it should be this wall, correct. West should be this one, right? And the last one, south, which should be the bottom one. Alright, so that's pretty much it. We have all the values stored, and it is working damn fine. What I'm going to do now is I'm going to make this cells object or variable, what will you call it, array, private, because I won't be accessing this from outside, from the inspector. So I'm just going to make it private. I don't really need it now. Okay, now if I go back, and there you go. So if I run it now, okay, I'm going to create a 5x5. Alright, that's pretty much it, and yeah, so I have all the values stored. Now the system remembers what wall is belong to which cell, and yeah, that's pretty much it. Now in the next episode we might apply the depth first search to complete this maze system, but for now that's pretty much it. I'll see you guys later, and yeah, goodbye.